Getting the best results, the right quantity and quality of distortion from a virtual guitar amp requires two things. Getting the DI'd guitar signal into the DAW cleanly via an appropriate instrument input with the correct gain and input impedance to handle the signal, and then setting the level of that incoming signal to the optimal value to interface with the amp sim. But the best way to make this level setting might not always be that obvious. You're likely to encounter a number of gain controls on the interface itself and within the virtual amp plugin. You can just blindly turn knobs until you get a decent sound, but that could be a mistake. To ensure that you're getting the best distortion quality the plugin is capable of, you'd be better off if you calibrate the level of the incoming guitar signal to the virtual amp. I've often heard a guitarist complain that such and such amp sim doesn't sound and feel at all like the real thing. But then when I check out the hookup, I can see that they're hitting the plugin with levels that are completely different than what the real amp would see from a guitar, especially from the particular guitar they're using. Many virtual amps that are modeled from specific real amps are designed to respond as closely as possible to the real thing at the same settings of the virtual front panel knobs. That means not only the amount and specific character of the distortion, but the playing feel as well, how the amp responds dynamically to the player's touch. When real amps are pushed hard, their response, depending on their circuit design, can range from a tight response to a looser, more compressed feel, depending on, among other things, internal components, like the amp's rectifier circuit, which converts AC power to DC within a real amp. Modern solid-state or vintage tube rectifiers each provide a subtle but distinctly different feel, with the tube design having more so-called sag, or compression, when the amp is pushed hard. The best virtual amps model this kind of detail as well as the more obvious aspects like distortion and tone. And while subtle, model features like this can affect playing feel, and so performance, especially when it comes to solos. Even those amp models that aren't that specific in the behavior of the virtual front panel gain knobs are still likely to provide the appropriate amount of overdrive and response at more or less expected positions of the virtual amp's main drive or volume knob. But if the level of the guitar signal at the interface input is much lower or much higher than the guitar's level would be at the input of a real amp, then the sound and response at all positions of the model amp's virtual knobs may not be what's expected. Now, the player or engineer could turn the virtual amp's main gain knob up or down until he gets the level and amount of distortion he's looking for, but if that comes at a very different position of the knob than it would with the real thing, then other aspects of the modeling might yield a response that's not a good match for the expected actual response the real amp would provide. This often seems like a tweaky distinction to non-guitarists, but it's definitely something the player may notice and respond to negatively, especially an experienced guitarist who's played through the real amps being modeled and knows what that should both sound and feel like. For the best sound and most accurate or appropriate response from any amp sim, the level of the incoming guitar signal should ideally be calibrated to whatever level the model amp's designers had in mind when they set up the response characteristics of the models. Some virtual amp makers offer recommendations and controls for calibrating the level of the guitar input before it ever hits the model itself. They may recommend that maximum guitar levels correspond to more or less a certain level in dB on a standard channel strip meter, or a meter provided in a section of the plugin itself that precedes the actual amp sim. There may be separate, dedicated gain knobs for first calibrating signal input and then dialing up the desired distortion and response from the virtual amp being modeled. Not every amp sim is full-featured enough to provide this, though. Some leave you to your own devices to figure out and set the best incoming signal level. If the plugin has no dedicated input level calibration control, you have two options. You can set input level on the hardware with the level control for that input on the interface itself, or you could insert a generic gain or trim plugin just ahead of the amp sim and dial up the appropriate level there. If the plugin maker offers a recommendation, they might provide a calibrated level indicator in the plugin's pre-model input section, or suggest a peak or average input level anywhere from close to maximum to quite a few dB lower. If there's no dedicated input calibration section within the plugin itself, you can bypass it and reference the channel strip meter, set, of course, to display pre-fader input level. But how would you determine the best level for a particular brand of virtual amp or a specific amp model? Well, if you're intimately familiar with a particular amp and have an idea of what to expect at certain settings on the real thing, you could use that familiarity as a guide. Otherwise, there are some general similarities on how the main gain or drive knobs respond in different types of amps. For example, many vintage amps that go from clean to crunch, from 1 to 10 on the amp's input gain knob, might be relatively clean up to about 3 or 4 on the knob. And then from around 4 to 7, the full range of distortion may often suddenly or gradually kick in. With high-gain amps, however, it's not uncommon for heavier distortion to kick in at as low as 2 on the gain knob. You would have to have at least some familiarity with the type of amp being emulated, and obviously, even if you're not a guitarist, if you'll be recording and mixing guitar tracks, it would be a good idea to have a working knowledge of the main differences among types and brands of amps to be able to calibrate input level for the best performance from various models. And to complicate things further, besides the 2 different input level controls you may find on some amp sims, there may be 2 output controls as well, and often the virtual amp's front panel itself may have 2 gain controls that are part of the model. And that's where I'll pick up next time: the different types and models of real amps, and the specific behavior and response of the modeled front panel controls.